Imagine today is your first technical interview and your interviewer asks you this question. Let's imagine we have a 60-floor building with only two elevators. People from different floors can press the elevator button at the same time. Also, the elevator might already be moving up or down when new requests arrive. Your task is to design a system that decides which floor the elevator should go first, when the elevator should go up or down, and how we can reduce the waiting time for people. At first, I thought this was a simple problem, but once I started thinking about it, it became much more complicated. Let's understand why. My first approach was, what if the elevator simply goes to the nearest request first? Let's understand this with the help of an example. Imagine the elevator is currently at 10th floor, and suddenly new requests arrive from 11th, 12th, and 40th floor. If we always choose the nearest request, the elevator might keep moving up and down randomly, and people far away, like at 40th floor, might end up waiting forever. So, this approach is wrong. My next approach was, what if the elevator simply stops at each floor? Clearly, this was not a good approach because the elevator would stop at each floor, and this would waste a lot of time. Now, my final approach was, if the elevator is moving up, let it first serve all the upward requests. For example, if the elevator is currently at 10th floor and moving up, and new requests arrive from 11th, 12th, 35th, and 1st floor, then the elevator will first serve the upward request. So the movement will look like this. Now imagine that while the elevator is moving upward, someone suddenly makes a request from 22nd floor. Even then, the elevator will continue serving the existing upward request first. Once it reaches the highest request and there are no more floors above, the elevator changes its direction. Then it starts moving downward and serves the remaining requests, like 22nd floor and then the first floor. This reduces unnecessary movement and improves overall waiting time. This strategy is called elevator algorithm. Now let's understand this with the help of code. First, we have to create an elevator object that stores its current state, like this. Here we store the elevator's current floor, the direction it is moving, a list of floors requesting upward and downward movement. We create two separate lists because when the elevator is moving up, we only care about requests above the current floor. And when the elevator is moving down, we only care about requests below the current floor. Now, when someone presses the elevator button, the system checks like this. Is the requested floor above the current floor? If it is above, add it to up request. If it is below, add it to down request. For example, elevator is currently at 10th floor and suddenly requests arrive from 15, 20, and 5. Since 15 is above 10, it goes to up request. Similarly, 20 is above 10, it also goes to up request. But 5 is below 10, so it moves to down request. Now, if the elevator is moving up, we must remember these three things. First, sort the upward request. Then, visit them in order. Finally, stop at each requested floor. Once all upward requests are completed, the elevator changes its direction. If the elevator is moving down, the same logic is applied to downward requests. And that's how you can solve a real world interview question using a simple algorithm. But here's something for you to think. What if the building had 100 floors and 4 elevators? How would you design that system? Let me know in the comments. And if you enjoyed this video, don't forget to like, share, and subscribe to our channel for more such interesting interview questions. See you in the next video. Thank you.